resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to the Chand Academy. The book IIT-JEE Mains and Advanced by ML Khanna Sir is before you, and all the videos chapter wise to boost your preparation by me, Subuh Nadeem, BTech and MTech IIT Delhi. Do share, like, subscribe this channel and also click the bell notification to get all the recent notifications. Now let us start with the second chapter, and that is complex numbers. So first let us see some basic concepts here, and those basic concepts I will just describe to you. First is modulus of a complex number. What is modulus of a complex number? Mod of z, that is root over x square plus y square, where z is equal to x plus iy. Now here mod z also means geometrically distance of z from origin. This is mod of z. It can be on any axis, it can be on any quadrant. Now what are the properties of mod of z? z1 by z2 mod is equal to z1 mod by z2 mod. z1 into z2 mod is equal to z1 mod into z2 mod. For addition and subtraction you cannot split mod like this. So we don't have that property similar to these for addition and subtraction. Next we have is conjugate. What is conjugate of a complex number? Z dash, that is x minus iy, where z is equal to x plus iy. So geometrically it means the mirror image of z about the x axis. So if we have z somewhere here in the second quadrant, z conjugate will be here, the third quadrant. If it is in the first quadrant, it will be in second quadrant. So what are the properties? So z1 into z2 conjugate is z1 conjugate into z2 conjugate. z1 upon z2 conjugate is equal to z1 conjugate upon z2 conjugate. Here addition and subtraction also follows the law of splitting. So z1 plus z2 conjugate is conjugate of z1 plus conjugate of z2, and similarly z1 minus z2 conjugate is equal to conjugate of z1 minus conjugate of z2. One more important property of modulus and conjugate combined is z into z conjugate is mod of z square. So this is how we describe conjugate and its properties. Next we have here is argument. Argument of a complex number. How do we find argument of z, where z is equal to x plus iy? So in order to find argument, we first take theta, which is tan inverse of mod of y by x. Now we decide in which quadrant it lies. So if z is in the first quadrant, the argument of z is same as theta. If it is in second quadrant, the argument of z, which is like this, is equal to pi minus theta. If it is in the third quadrant, argument of z is equal to minus pi plus theta. And the fourth quadrant, argument of z is equal to minus theta. So this is the concept. Further, argument of z1 into z2 is equal to argument of z1 plus argument of z2 plus 2k pi, where k is an integer. Similarly, argument of z1 by z2 is equal to argument of z1 minus argument of z2 plus 2k pi. Here again k is an integer. We add this 2k pi so that we want a principal value range of argument which is from minus pi to pi. So argument of z always lies between pi to minus pi. So this addition is done to compensate any extra addition or extra subtraction. Next we have here is de Moivre's theorem. So what is de Moivre's theorem? De Moivre's theorem says that if you take in polar form a complex number cos theta plus I sin theta raised to the power n, where n is any integer, then this will be cos n theta plus iota sin n theta, where n is belonging to any integer, positive or negative or 0 also. Also you can say e to the power I theta to the power n is equal to e to the power I n theta in Euler form. Next is cube root of unity. Cube root of unity we have is 1 omega square. How do we obtain cube root of unity? If we take z cube is equal to 1, this will give you z cube minus 1 cube is equal to 0. So z minus 1 into z square plus z plus 1 is equal to 0. From there we will get z is equal to 1, and from the second one we will get z is equal to minus b plus minus root 3 iota by 2, which is omega and omega square. Plus you can take omega and minus you can take omega square, or you can take converse of that also, but both cannot be same. So what are the properties? 1 plus omega square is equal to 0, omega cube is equal to 1, and 1 plus omega to the power n plus omega to the power 2n is equal to 3 if n is a multiple of 3 and 0 otherwise. That means it is not a multiple of 3. So these are some of the properties of cube root of unity. Next we have nth root of unity. So nth root of unity, what does it says? That we have z to the power n is equal to 1 is having roots 1 alpha square dot alpha to the power n minus 1, and these values are cos 2k pi by n plus iota sin 2k pi by n, where k varies from 0, 1, 2 till n minus 1. So these are nth roots of unity. Further, you can also write it as e to the power I 2k pi by n in Euler form. Properties are like this: 1 plus alpha square so on till alpha to the power n minus 1 is equal to 0. Then we have Coni's rule. Coni's rule says that if we take a complex number z1 and a complex number z2 from origin, then z2 by z1 is equal to mod of z2 by z1 e to the power iota, the angle between them is theta, so e to the power I theta. This theta is taken anti-clockwise when we are moving from z1 to z2, from denominator to numerator. If it is clockwise, then we will take minus theta. So theta is anti-clockwise, that you have to keep in mind. And if you take instead of origin z3, then the same Coni's rule become like this: z2 minus z3 by z1 minus z3 is equal to mod of z2 minus z3 upon z1 minus z3 e to the power I theta. Again theta is the angle like this, anti-clockwise from the arm z1 z3 to the arm z2 z3. So these were some of the basic concepts which are very important to solve the questions of complex numbers. Now we'll move on to questions. show that a real value of x will satisfy the equation 1 minus iota x upon 1 plus iota x is equal to a minus iota b if a square plus b square is equal to 1, where a, b are real. So in order to do this question, what we will do, we will take mod both the sides. So when you will take mod both the sides, by the property of mod which I told, this will become 1 minus iota x mod upon 1 plus iota x mod, that is z1 by z2 mod is equal to z1 mod by z2 mod is equal to mod of a minus iota b is root over a square plus b square. This implies 1 minus iota x mod is root over 1 plus x square, because minus x whole square is also x square, divided by root over 1 plus x square is equal to root over a square plus b square. So you can mention here that you have applied which property? You have applied z1 by z2 mod is equal to z1 mod by z2 mod in here. Now this will become 1 is equal to root over a square plus b square. So you will get, after squaring, a square plus b square as equal to 1, which we had to prove. Right? Now let us see the next question. Prove that minus 1 plus root 3 iota, because minus root 3 is under root, that is root 3 iota by 2. So this is nothing but omega to the power 100, and this is actually omega square to the power 100, that is minus 1 minus root 3 iota. This is actually, this one is root 3 iota, and this is also root 3 iota. There it is plus, here it is minus, and then you will add them and you have to show that it is equal to minus 1. So this is omega to the power 100 plus omega to the power 200. Now omega cube is equal to 1, we already know. So in that situation, omega to the power 99 will also be 1. It is a multiple of 3. So here it will be omega into omega to the power 99. Here again omega to the power 200 is omega to the power 2 into omega to the power 198. And this omega to the power 198 is also equal to 1, because 198 is also multiple of 3. So this is omega into 1 plus omega square into 1, which is omega plus omega square, which is equal to minus 1. So this is what we had to prove. This is equal to minus 1. Thus it is true. This is another question. If iota is root over minus 1, then 4 plus 5, and this thing which is inside this power of 334, this is omega. This is omega. And this is also omega, same omega, because this is also plus, this is also plus. It is not minus. So don't get confused that one is omega, another is omega square. Both are same, both are omega, or you can take both as omega square. But don't take one as omega, another as omega square here. So this will be 4 plus 5 omega to the power 334. And then we have plus 3 omega to the power 365. So this will become 4 plus, now 334, is it a multiple of 3? No. But after dividing by 3, you get a remainder 1. So this will become 5 omega. And 365, when you will divide by 3, you will get remainder 2. So 3 omega square. So this is 4 plus 5 omega plus 3 omega square. Now you can write it at like this: 1 plus 3 plus 2 omega plus 3 omega plus 3 omega square, 3 omega square plus 3 omega plus 3. 1 plus 2 omega you take common, plus 1 3 you take common, 1 plus omega square. Now do you remember what we discussed? 1 plus omega square is 0. So this is value is 0. So 1 plus 2 omega. Now what is omega? Omega we already took, minus 1 plus root 3 iota by 2, as we took it here. So this will become 2 cancel, and then 1 minus 1 plus root 3 iota. It will also cancel, you will get root 3 iota. So your answer will be option C, that is root 3 iota. So if you are liking this video, you should go and just like, share and subscribe the channel, and also go to the bell notification for subscribing for all the future videos. If x square minus 2x cos theta plus 1 equal to 0, prove that x to the power 2n minus 2x to the power n cos n theta plus 1 is equal to 0. So this first one is given to us. From here what we can say that x square minus 2x cos theta plus 1 is equal to 0, which implies x is equal to minus b plus minus root over b square minus 4ac upon 2a. So this will be 2 cos theta plus minus 2 cos square theta minus 1 is minus sin square theta. So iota sin theta upon 2. This is cos theta plus minus iota sin theta. You can also say e to the power I theta and e to the power minus I theta. You can take any value of x and you can proceed. So I am taking for simplicity this value of x, but you can take e to the power minus I theta also. Now let us come here, x to the power 2n minus 2x to the power n cos theta plus 1. We have to show that this is equal to 0. So what you will do, x is e to the power I theta, which is cos theta plus I sin theta to the power 2n minus 2 x to the power n is cos theta plus I sin theta to the power n into cos theta, it is cos n theta. So this is cos n theta plus 1. Now apply De Moivre's rule. What was De Moivre's theorem? This power will multiply with theta. So this will become cos n theta plus I sin n theta, and here it will become n multiplied here minus 2 cos n theta plus I sin n theta into cos n theta plus 1. Right, also apply De Moivre's theorem. So this will become cos n theta, 2n theta plus iota sin 2n theta, and here minus 2 cos n theta into cos n theta is minus 2 cos square n theta, minus 2 iota sin n theta cos n theta is minus iota sin 2n theta plus 1. So this will getting cancelled. So this is cos 2n theta, and this is 1 minus 2 cos square n theta. If you take minus as common, 2 cos square n theta minus 1 is cos 2n theta. Trigonometric identity. This will also cancel and it will equal to 0, which we wanted to find it out. You can say here using trigonometric identity. This is one more question about nth root of unity. 1 omega square till omega to the power n minus 1 are the nth roots of unity. Then you have to show that 1 minus omega, you have to find out 1 minus omega into 1 minus omega square dot 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 into 1 minus omega to the power n minus 1 equals. So we know if z to the power n minus 1 is given, we can know its roots. N roots of unity are 1 omega square till omega to the power n minus 1. So we will say z minus 1, z minus omega square. These are the factors, right? Z minus omega to the power n minus 1. Now in the next step, this will be z to the power n minus 1 upon z minus 1 is equal to z minus omega square dot 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 z minus omega to the power n minus 1. Now how can you write this one? This can be written as 1 plus z plus z square, so on till z to the power n minus 1. You can see this is a GP. So you can make this formula from GP. First term is A, 1. R is common ratio, r to the power n minus 1 by r minus 1. And on the right side, z minus omega square dot z minus omega to the power n minus 1. Now what you need to do? You need to put z as 1. So this will become 1 plus 1 plus 1, because any power of 1 is 1. Is 1 minus omega square into 1 minus omega to the power n minus 1. You can mention that substitute z as 1 because it is an identity. So identity is true for all z. This is how many 1 are there? N. N is equal to 1 minus omega square, 1 minus omega cube, so on till 1 minus omega to the power n minus 1. So this is actually equal to n. So the value equals to n. This is our answer. Now let us come to this question. Let z1 and z2 be roots of the equation z square plus pz plus q equal to 0, where the coefficients p and q may be complex numbers. Let a and b represent z1 and z2 in the complex plane. If angle AOB is equal to alpha not equal to 0 and OA is equal to OB, where O is the origin, prove that p square is equal to 4q cos square alpha by 2. So this is again of Coni's rule, which was the last topic which we have studied. So according to the question, z square plus pz plus q is equal to 0 means the sum of the roots is equal to minus p and product of the roots is equal to q. The coefficients p and q may be complex numbers. Let a and b represent z1 and z2 in the complex plane. So a and b are representing z1 complex number and z2 complex number. This is the origin. If angle AOB is equal to alpha, this angle is alpha, and OA is equal to OB, this length and this length is same, where O is the origin, you have to prove this equation. So what we have to do by Coni's rule, z2 by z1 is equal to mod of z2 by z1 e to the power I alpha, right? Now z2 by z1 mod is 1 because mod of z1 by mod of z2, you can do one thing, you can write here that mod of z1 by z2 is actually mod of z1 by mod of z2, which is equal to 1 by 1, which is 1, or same, not 1 by a1 but a by a, because both are of the same length. Na? It is already given that OA is equal to OB. So mod of z1 and mod of z2 is same, it is 1. So e to the power I alpha, z2 is equal to z1 e to the power I alpha, right? Now you have to prove p square is equal to 4q cos square alpha by 2. So what we will do here, z1 plus z2 whole square is actually p square, right? This minus p square is p square, which is z1 plus z2 whole square. This is z1 square plus z2 square plus 2z1 z2. Now z1 z2 is q, so this portion is 2q plus z1 square plus z2 square. Now what we do for z1 square and z2 square, we can write it as 2q plus z2 square is z1 square e to the power iota 2 alpha. So you take z1 square as common, 1 plus e to the power iota 2 alpha. So this will become 2q plus 1 plus e to the power iota 2 alpha. So e to the power iota 2 alpha is cos 2 alpha plus iota sin 2 alpha, right? And what is 1 plus cos 2 alpha? That is 2 cos square alpha by 2. So z1 square 2 cos square alpha by 2, or this is 2 alpha, then half of that is alpha, plus iota sine 2 alpha. 2q plus z1 square, and this is 2 cos alpha can be taken as common, and cos alpha plus iota sine alpha. So 2q plus z1 square into e to the power I alpha into 2 cos alpha. Now z1 e to the power I alpha is z2. So this becomes 2q plus z1 into z2, 2 cos alpha. And what is z1 into z2? That is q. 2q plus q 2 times cos alpha. Now you take 2q as common, then 1 plus cos alpha, which can be written as 2 cos square alpha by 2. So this is finally 4q cos square alpha by 2. So 4q cos square alpha by 2, that is what we had to prove. So we have proved that. Let us come to the next question. If omega not equal to 1 is a cube root of unity, this is cube root of unity, and 1 plus omega to the power 7 is equal to a plus b omega, then a and b respectively given by. So you have to find the values of a and b. Here 1 plus omega can be written as minus omega square. Why is it so? Because 1 plus omega square is equal to 0. Sum of the cube roots of unity is equal to 0. When we substitute it here, this will be minus omega square to the power 7 is equal to a plus b omega. Now this will become minus omega to the power 14 is equal to a plus b omega, where omega to the power 14 is equal to omega square into omega to the power 12, and omega to the power 12 is 1 because it is a multiple of 3, 12 is a multiple of 3, so omega square we will get. So this will become minus omega square is equal to a plus b omega. Now again minus omega square we know is 1 plus omega, so 1 plus omega is equal to a plus b omega. Now if you see the left hand side and the right hand side, the constants and the coefficients of omega are equal. So you can say that a is actually equal to 1 and b is actually equal to 1. So the option that you have is option number C, 1, 1. The other factor which we have used here is omega cube is equal to 1. So this is also important. Now let us come to the next question. If z is any complex number satisfying z minus 3 minus 2 iota mod is less than equal to 2, then the minimum value of 2z minus 6 plus 5 iota mod is. Now, here first of all you have to understand that mod of z minus z naught is equal to r represents a circle. What type of circle is it? It is a circle which is having a center z naught and having a radius r. So this is such a type of circle. Z is on the circumference of the circle any point. Now when we see the equation here, it is z minus 3 plus 2i mod is less than equal to 2, not equal to 2. So let us take equal to 2. If we take equal to 2, what will happen? This is I here, so don't get confused. This is I. So if it is equal to 2, then it will be a circle whose center is z naught 3, 2. So 3, 2 is 3, 2 somewhere here, and its radius is 2. So it is touching the x-axis at this point. So this is the equation of the circle. Now if we change it into z minus 3 plus 2i less than equal to 2, what will happen? Then instead of circumference, you will also get the points inside the circle. So points inside the circle will also be obtained, and on the circumference is already there because equality is there. Now the minimum value of 2z minus 6 plus 5i is, so you can write this as 2 common mod of z minus 3 minus 5i by 2 like this. Why we have done this? Because we have to find the minimum value of this term where Z coefficient is 2. So we wanted to make it like this, so that for this Z coefficient is 1. Now Z minus this one is Z1. So Z1 let us plot 3 comma minus 5 by 2. This is 3 minus 5 by 2 will be somewhere here. So this is 3 comma minus 5 by 2 Z1 point. Now Z is somewhere on the or inside this circle. Z is in this region. And its distance from Z1, mod of Z minus Z1 means, mod of Z minus Z1 means distance between Z and Z1. So mod of Z minus Z1 is distance between Z and Z1. So distance between a point on this circle or inside the circle with this Z1 has to be minimum. When it will be minimum? When this point is taken. Then this distance will be the minimum distance. And this distance is 5 by 2 units. Magnitude is 5 by 2. So you can say that the minimum distance is 5 by 2. But you have to multiply a 2 also, because 2 times of this is given. So 2 into 5 by 2 is equal to 5. This is the minimum distance. This will be your answer. Let us come to the next question. The number of complex numbers Z such that mod of Z minus 1 is equal to mod of Z plus 1 is equal to mod of Z minus I equals. Again, one thing you have to remember, that Z minus Z1 mod is equal to Z minus Z2 mod represents a bisector of a line segment. Which type of line segment? A line segment joining Z1 and Z2. So if there is a line segment joining Z1 and Z2, there is a bisector of this line segment, and this bisector has many points like Z here, so that Z minus Z1 and Z minus Z2 mod is same. So this is the line segment bisector. So if you take the equation this one, then one point is 1 comma 0, another point is minus 1 comma 0, and Z will be obviously lying on the y axis. This is the perpendicular bisector of this line segment AB. Now you have to take another point which is iota. Iota is somewhere here, 0 comma iota. So Z distance with iota is equal to Z distance with minus 1. So that means this line segment, which you can see here, this line segment is having a perpendicular bisector, and this perpendicular bisector will pass through the origin. So the red line and this blue line, which is at some angle, they are intersecting at origin. So you can say that overall there is only one point which is common to both the perpendicular bisectors, that is the origin. So you will say the number of complex numbers Z such that this is equals is actually 1. So it is 1, which is your answer, and that value is 0. If xr is equal to cos pi by 2 to the power r plus I sin pi by 2 to the power r, prove that x1, x2, x3 till infinity is equal to minus 1. So we have to show this. Here again, x1 will be cos pi by 2 plus iota sin pi by 2 into cos pi by 4 plus iota sin pi by 4. Similarly, cos pi by 8 plus iota sin pi by 8. These terms go till up to infinity. Now, by de Moivre's theorem, what we can do? We can add the angles inside the cos as well as inside the sine. So, pi by 2, pi by 4, pi by 8 till infinity plus iota sine pi by 2, pi by 4. First it is pi by 2, then pi by 4, then pi by 8 till infinity. So, this is a GP, if we take pi as common, and its first term is half upon 1 minus r, that is also half, because it is sum till infinity. So the sum till infinity of a GP we all know is a plus ar plus ar square till infinity is a upon 1 minus r. Similarly, iota sine pi common, 1 by 2 here also, 1 minus 1 by 2 here also. So this will be equal to, here it is 1 by 2 upon 1 by 2, that is 1. So it will become cos pi, and for the next term it is sin pi. Cos pi is minus 1 and sin pi is 0. So you get minus 1 as your answer. So this is minus 1. In the next question, we have to prove that the product of any two of the 10 tenth roots of unity is again one of the 10 roots. So let us suppose 10 tenth root of unity are 1 alpha alpha square alpha cube till alpha to the power 9, where what is alpha? Alpha is cos of 2, this is alpha, alpha is equal to cos of 2 pi by k, 2 pi by 10 it will be, because it is 10th root, na, right? So it will be 10 plus iota sine 2 pi by 10, or you can also say e to the power I 2 pi by 10. This is alpha. Similarly, alpha square will be 4 pi by 10, then 6 pi by 10, so on till 18 pi by 10. Now it is saying that product of any two of the 10th roots of unity is again one of the 10 roots. Suppose we take randomly alpha square into alpha to the power 9, two 10th roots of unity. This will become alpha to the power 11. And we know that alpha to the power 10 is equal to 1. Why is it 1? Because it is a 10th root of unity. So its power 10 is 1. So this will be 1 into alpha, which is alpha 1 of the 10th root of unity. So randomly you can take any two, like you take alpha to the power 4 into alpha to the power 8. So this will become alpha square. First it will become alpha to the power 12. Then you write it as alpha to the power 10 into alpha square. So 1 into alpha square is alpha square. So this is also one of the 10th roots of unity. So in this manner you can see that you find that this statement is actually true. So this is how we can do this question. So this is all for today's session, student. Keep working hard. Thank you.